Top 25 Quality Engineer Interview Questions and Answers. Preparing for a quality engineer interview requires a strong understanding of quality management principles, problem-solving techniques, manufacturing standards, and continuous improvement practices. Employers expect candidates to demonstrate analytical thinking, technical expertise, and the ability to ensure products or services meet required specifications and customer expectations. This interview guide is designed to help candidates confidently prepare for common quality engineer interview questions. Each question focuses on practical workplace scenarios, quality tools, teamwork, and process improvement strategies. By studying these answers, candidates can develop structured responses that highlight their professional experience, technical knowledge, and commitment to delivering consistent quality results. 1. What is the role of a quality engineer? A quality engineer ensures that products, processes, and systems meet defined quality standards and customer expectations. Their responsibilities include developing quality procedures, conducting inspections, analyzing defects, and implementing corrective actions. They collaborate with production, design, and supply chain teams to prevent quality issues rather than simply detecting them. Quality engineers also monitor performance metrics, lead audits, and support continuous improvement initiatives. By applying statistical tools and quality methodologies, they reduce waste, improve efficiency, and enhance product reliability. Their ultimate goal is to maintain compliance with industry standards while delivering consistent and high-quality outcomes. 2. What are quality management systems, QMS? A quality management system is a structured framework used to manage and improve organizational processes to ensure consistent product or service quality. It includes documented procedures, policies, objectives, and responsibilities that guide operations. Quality engineers implement QMS standards, such as ISO requirements, to ensure compliance and efficiency. The system focuses on customer satisfaction, risk management, process control, and continuous improvement. Through audits, performance monitoring, and corrective actions, QMS helps organizations minimize defects and improve productivity. A strong QMS promotes accountability, clear communication, and standardized workflows across departments. 3. Explain the importance of ISO 9001. ISO 9001 is an internationally recognized standard for quality management systems. It helps organizations establish structured processes that ensure consistent quality and customer satisfaction. Quality engineers use ISO 9001 principles, such as risk-based thinking, leadership involvement, and continuous improvement to enhance operational performance. Certification demonstrates commitment to quality and increases customer trust. It also improves documentation control, process monitoring, and corrective action management. Implementing ISO 9001 reduces errors, improves efficiency, and strengthens organizational credibility. Companies following this standard often achieve better market competitiveness and operational excellence. 4. What quality tools are commonly used? Quality engineers frequently use tools such as Pareto charts, fishbone diagrams, control charts, histograms, check sheets, scatter diagrams, and flowcharts. These tools help identify root causes, monitor performance trends, and analyze process variations. For example, Pareto analysis highlights major defect contributors, while control charts track process stability. Using structured tools enables data-driven decision-making instead of assumptions. Quality engineers select tools based on the problem type and project requirements. Proper use of quality tools improves process understanding, reduces defects, and supports continuous improvement initiatives across manufacturing or service environments. 5. What is root cause analysis? Root cause analysis is a systematic approach used to identify the underlying reason behind a problem rather than treating symptoms. Quality engineers apply techniques such as the 5 whys, fishbone diagrams, and failure mode and effects analysis to uncover process weaknesses. The goal is to eliminate recurring issues by implementing effective corrective actions. Root cause analysis involves collecting data, analyzing contributing factors, verifying causes, and validating solutions. This method reduces repeated defects, improves reliability, and strengthens operational performance. Effective root cause analysis promotes long-term problem prevention instead of temporary fixes. 6. What is Six Sigma? Six Sigma is a data-driven methodology focused on reducing process variation and defects. It follows the DMAIC framework: define, measure, analyze, improve, and control. Quality engineers use statistical analysis to identify inefficiencies and improve process capability. Six Sigma aims for near-perfect performance by minimizing errors and improving consistency. Professionals often hold certifications such as Green Belt or Black Belt. Implementing Six Sigma enhances customer satisfaction, lowers operational costs, and improves productivity. It encourages evidence-based decision-making and continuous improvement culture within organizations. 7. Explain Statistical Process Control, SPC. Statistical process control involves monitoring production processes using statistical methods to ensure stability and consistency. Quality engineers use control charts to track variation and identify trends before defects occur. SPC distinguishes between normal process variation and special causes requiring corrective action. By analyzing real-time data, engineers prevent defects rather than detecting them after production. SPC improves efficiency, reduces scrap, and enhances product reliability. Implementing SPC supports proactive quality management and ensures processes remain within acceptable control limits. 8. What is corrective and preventative action, CAPA? Corrective action addresses existing problems by identifying causes and implementing solutions to prevent recurrence. Preventative action focuses on identifying potential risks before issues occur. Quality engineers manage CAPA processes through investigation, documentation, implementation, and effectiveness verification. CAPA systems improve compliance, reduce nonconformities, and enhance operational reliability. Proper CAPA management strengthens quality culture by encouraging continuous monitoring and proactive risk management. Organizations use CAPA as a key element in regulatory compliance and quality system improvement. 9. What is failure mode and effects analysis, FMEA? FMEA is a risk assessment tool used to identify possible failure modes in a process or product and evaluate their impact. Quality engineers assess severity, occurrence, and detection ratings to calculate risk priority numbers. This helps prioritize improvement efforts. FMEA encourages proactive risk prevention during design or process development stages. By addressing high-risk areas early, organizations reduce defects, improve safety, and enhance reliability. FMEA supports structured decision-making and continuous quality improvement. 10. How do you handle customer complaints? Handling customer complaints requires structured investigation and professional communication. A quality engineer gathers detailed information, analyzes root causes, and collaborates with relevant teams to implement corrective actions. Timely response and transparency are essential for maintaining customer trust. Engineers document findings, monitor corrective actions, and verify effectiveness to prevent recurrence. Customer feedback provides valuable insights for product and process improvement. Proper complaint handling strengthens customer relationships and demonstrates commitment to quality excellence. 11. What is a quality audit? A quality audit evaluates whether processes comply with established standards and procedures. Quality engineers conduct internal or external audits to assess system effectiveness and identify improvement opportunities. Audits involve reviewing documentation, interviewing employees, and observing operations. Findings are categorized as conformities or nonconformities, followed by corrective action plans. Regular audits ensure regulatory compliance, process consistency, and continuous improvement. They also help organizations maintain certifications and improve operational transparency. 12. Explain continuous improvement. Continuous improvement focuses on ongoing enhancement of processes, products, and services. Quality engineers apply methodologies like Kaizen, Lean, and Six Sigma to eliminate waste and improve efficiency. Small, incremental improvements accumulate into significant long-term gains. Continuous improvement encourages employee involvement, innovation, and data-driven decision-making. Monitoring performance metrics and implementing corrective actions help sustain progress. Organizations adopting continuous improvement remain competitive and responsive to customer needs. 13. What is lean manufacturing? Lean manufacturing aims to maximize value while minimizing waste. Quality engineers identify non-value-adding activities such as overproduction, waiting time, defects, and unnecessary motion. Lean tools include value stream mapping, 5S, and standardized work practices. Implementing lean improves productivity, reduces costs, and enhances workflow efficiency. Quality engineers collaborate with production teams to streamline processes and maintain consistent output quality. Lean culture promotes efficiency and customer satisfaction. 14. How do you measure product quality? Product quality is measured using inspection results, defect rates, customer feedback, reliability testing, and performance metrics. Quality engineers establish key performance indicators aligned with product specifications. Statistical analysis helps monitor trends and identify improvement opportunities. Testing methods may include dimensional inspection, functional testing, or durability evaluation. Continuous monitoring ensures compliance with requirements and customer expectations. Measuring quality enables data-driven improvements and ensures consistent product performance. 15. What is process capability? Process capability evaluates how well a process meets specification limits. Quality engineers calculate indices such as CP and CPK to measure performance consistency. A capable process produces outputs within acceptable tolerance levels with minimal variation. Capability analysis helps identify improvement needs and supports database decisions. By improving process capability, organizations reduce defects, increase efficiency, and maintain predictable production outcomes. 16. Describe your experience with quality documentation. Quality documentation includes procedures, work instructions, inspection records, and audit reports. Quality engineers ensure documentation accuracy, accessibility, and compliance with standards. Proper documentation supports traceability, training, and process consistency. Engineers regularly review and update documents to reflect process changes. Effective document control prevents confusion, improves accountability, and supports regulatory compliance. Maintaining organized documentation is essential for audits and continuous improvement initiatives. 17. How do you manage supplier quality? Supplier quality management ensures incoming materials meet required standards. Quality engineers evaluate suppliers through audits, performance monitoring, and qualification processes. They analyze defect trends, establish quality agreements, and collaborate with suppliers to resolve issues. Continuous communication and performance metrics help maintain consistent supply quality. Effective supplier management reduces production risks and strengthens the overall supply chain. 18. What is non-conformance management? Non-conformance management involves identifying products or processes that fail to meet requirements. Quality engineers isolate affected items, investigate causes, and implement corrective actions. Documentation and traceability ensure accountability and regulatory compliance. Analyzing non-conformance trends helps prevent future defects. Proper management minimizes risk, reduces waste, and maintains customer confidence. 19. How do you ensure compliance with standards? Ensuring compliance requires regular audits, training programs, process monitoring, and updated documentation. Quality engineers align operations with regulatory and industry standards through structured procedures. They educate employees about requirements and verify adherence through inspections and performance reviews. Continuous monitoring and corrective actions maintain compliance and reduce operational risks. Compliance ensures product safety, reliability, and organizational credibility. 20. Describe a time you solved a quality problem. When facing a quality issue, I first collected data and defined the problem clearly. I performed root cause analysis using structured tools and collaborated with cross-functional teams. After identifying the root cause, corrective actions were implemented and monitored for effectiveness. Performance metrics confirmed improvement, and preventative measures were introduced to avoid recurrence. This systematic approach improved product consistency and reduced defects significantly. Problem-solving requires analytical thinking, teamwork, and continuous monitoring. 21. What is risk management in quality engineering? Risk management involves identifying potential failures and implementing preventative measures before problems occur. Quality engineers assess risks using tools like FMEA and risk matrices. Prioritizing high-risk areas allows efficient resource allocation. Risk management enhances product reliability, safety, and compliance. Proactive planning reduces operational disruptions and ensures consistent performance. Effective risk management supports long-term organizational success. 22. How do you work with cross-functional teams? Quality engineers collaborate with design, production, procurement, and customer service teams. Effective communication ensures alignment on quality goals and problem resolution. Engineers provide technical guidance, share performance data, and encourage teamwork during improvement initiatives. Cross-functional collaboration improves decision-making, accelerates issue resolution, and promotes shared responsibility for quality outcomes. Strong teamwork ensures sustainable improvements. 23. What key skills make a successful quality engineer? Successful quality engineers possess analytical thinking, attention to detail, communication skills, and technical knowledge. Problem-solving ability and data analysis expertise are essential. Knowledge of quality standards, statistical tools, and process improvement methods enhances performance. Adaptability and teamwork help manage complex challenges. Strong organizational skills ensure effective documentation and compliance management. Continuous learning is vital in evolving industries. 24. How do you prioritize multiple quality tasks? Prioritization involves assessing risk, urgency, and business impact. Quality engineers focus first on issues affecting safety, compliance, or customer satisfaction. Using project management tools and performance metrics helps allocate resources efficiently. Clear communication with stakeholders ensures expectations are aligned. Effective prioritization maintains workflow efficiency while addressing critical quality concerns promptly. 25. Why should we hire you as a quality engineer? You should hire me because I combine technical expertise with a strong commitment to continuous improvement. I bring experience in quality tools, root cause analysis, process optimization, and compliance management. My approach focuses on preventing defects, improving efficiency, and supporting organizational goals. I collaborate effectively with teams and use data-driven methods to achieve measurable results. My dedication to quality excellence ensures reliable products, satisfied customers, and long-term business success. A quality engineer plays a vital role in ensuring products and processes meet high performance and reliability standards. Successful candidates demonstrate strong analytical abilities, technical knowledge, and commitment to continuous improvement. Preparing structured answers to common interview questions helps candidates confidently communicate their expertise and professional value. This guide provides practical insights into quality management systems, problem-solving methods, and industry best practices. By understanding these concepts and practicing responses, candidates can perform effectively during interviews and position themselves as valuable contributors dedicated to maintaining quality excellence and organizational success.